Hello, everyone. My name is Brandon Tomas, and my presentation is on the recent research on synesthesia. So just an overview. First, I'm going to just go over what synesthesia is, some types of it, and then I'm really going to focus on empirical studies with grapheme color synesthesia and spatial sequence synesthesia, and then I'm just going to go over some conclusions. So the purpose of this was to explore different aspects of research associated with synesthesia through various empirical studies. I tried to pick out studies that were different and addressed different methods and kind of showed the range of the types of studies associated with this. So the methods were definitely a focus, and I really, again, focused on the two types of synesthesia just because they were very common. What is synesthesia? Synesthesia is really just the overlap of sensory systems. So in this example, or in this picture below, it just shows like different colors of letters, like in grapheme color synesthesia, where you associate colors with certain letters or numbers. And this is just an example I pulled, or a definition I pulled from Google. They're all relatively similar. They mean the same thing. It's just different ways of putting it. Some types of synesthesia. There's grapheme color synesthesia, chromesthesia, spatial sequence synesthesia, number form, auditory, tactile synesthesia, ordinary linguistic personification, misophonia, lexical, gustatory synesthesia, and kinesthetic synesthesia. And these are just some of the types. The names could differ slightly for some of them. I'm not really going to get into each one just because I want to focus more on GCS and SSS. So getting into the grapheme color synesthesia, there are 3 empirical studies, and just to clarify, grapheme color synesthesia is the involuntary and automatic association of colors with numbers or letters. Now, the first study I did was, or I looked at, was on visual processing with GCS by Adgerson et al. In 2015. The purpose was how visual processing of colored letters is affected by the congruence or incongruence of synesthetic grapheme color associations. So congruence meaning, is that association the same association that they would typically make due to their synesthesia? The way they tested this was they presented graphemes for 10 to 150 milliseconds to 9 grapheme color synesthetics or synesthetes and 9 controls. And then they would have to report those back. And they used a mathematical model to evaluate this, Bergen's 1990 theory of visual attention. And that was fitted to each curve in which they combined variables to be able to compare them. And this is just an example of what like the pairs of colored letters look like. And this is the data. The important thing to take away is just that there is a difference, and I kind of just wanted to show what it looked like. It is very complex, and unfortunately, I don't have enough time to unravel all of it, but I think this does a good job of just representing their findings. And those findings being that synesthetics or synesthesia affects processing of letters at a perceptual level. Synesthetic associations become intense or intensified in categories of graphemes, and it would obviously depend on that category. Enhanced visual STM or short-term memory for the congruent letters, and also congruence boosted synesthetes performance by about 3.9%. So that isn't too surprising considering that's just what they would normally do. The next study was a double-blind procedure, and they suspected that people who would be selected unblindly, and that there was biases coming in throughout different stages of the research associated with visual imagery and GCS. So they did that double-blind procedure to get rid of that bias, specifically when selecting them. And they replicated studies of the visual imagery usage. So, and they used the spontaneous use of imagery scale, or the SUIS, to quantify this. And this was for the methods. This was performed at the University of Michigan. The pre-screening involved 60 questions, and the participants had to wait 3 weeks after that pre-screening just to get rid of any sort of bias. And these participants, as you can see in the figure to the right, it kind of gives a demographic of them. But there are 4 types. There's non-synesthetes, there's the confirmed synesthetes, or GCS specifically, and then there's potential GCS, which is they might have it. Their diagnostic data was more ambiguous. And then there's also some with other types of synesthesia. So the confirmed synesthetes reported significantly greater visual imagery usage compared to the non-synesthetes. And when the potential and the verified synesthetes were compared to the non-synesthetes, it was also the same. Synesthetes are more aware of their selection typically when they self-identify. So that's definitely an area of bias. There's also expectation bias that goes both ways. And self-selected synesthetes, people who kind of self-identify, are or may be different from just verified synesthetes. The next study was rule-based category learning in GCS, and that was performed by Watson et al. In 2012. Participants learned through trial and error to classify basically different grapheme pairs that were categorized on the basis of the synesthetic associations with color. So they learned to categorize these more efficiently. They were able to transfer this learning to new stimuli. They also falsely recognized grapheme pair like foils. And synesthesia may be explored in the kind of material, or maybe exploited in the type of material learned in various different classroom settings, just because it wouldn't comply with those associations. But overall, the performance among the two, they were known to be, or were found to be, very similar. Now, switching gears to spatial sequence synesthesia, empirical studies in spatial sequence synesthesia, or SSS, is just the visualization of numbers, of number sequences in physical space. So the first study was on spatial imagery skills, and that's to see whether SSS is linked to spatial imagery comparing synesthetes to non-synesthetes using the Object Spatial Imagery Questionnaire, or the OSIQ, and they also tested it using mental rotation and a paper folding task, which are known to be very enhanced for people with SSS. And like a lot of other studies, this was a replication, and the replication, or the data that they are replicating, found no real significant difference between the control and the synesthetes. And the results were consistent for, like, the spatial imagery were consistent with self-reports. And they also suspect that the visual abilities are more enhanced than the spatial. In the methods, there were 9 synesthetes and 8 controls, but they did use a lot of pooled data for further analysis. There's 15 statements of visual imagery and 15 of spatial imagery, and then also the mental rotation and paper folding tasks, which lasted about an hour. And this was really dependent on like time and accuracy, especially for the mental rotation. And just some of the major results, the scores were higher for the visual subscale, but not the spatial. Correlation between spatial OSIQ, but not visual. The PFT, or the paper folding task, was different for synesthetes, or wasn't, it really was not different. And then the mental rotation was the same for both accuracy and response time, but there was a positive correlation also with the paper folding task for the OSIQ, for, like I said, for both. But there was really no indication of any sort of advantage for synesthetes. The next study really dealt with the diagnostics. I just wanted to briefly run through this one just because I thought it was kind of similar to the double blind, where they would actually test the method used. And this builds on previous research like other studies that I've mentioned. And this deals with the spatial locations and how that can be used to diagnose SSS, and primarily focusing on that sensitivity and the specificity. So they had 70 participants, 33 potential SSS, and then 47 controls. So this was fairly decent sized. So they would identify locations on a screen, 3 occasions for each stimuli, and they would find like the frequency of each location, and they did this through triangulation. And this is kind of like a chart that they would use to diagnose it, and they found that 9 out of 10 synesthetes can be diagnosed through this method. And then the next study is the enhanced spatial navigation skills. So they really focused on the cognitive benefits. So spatial navigation to explore if their enhanced sensitivity to spatial relations is reflected by their enhanced navigational performance. So the questionnaire, they used a questionnaire for this, for actually identifying people for the study. They used a consistency test and also drawings, which was a bit different from some of the ones in the past. They also used a maze task, and this really involved, it was a pretty long sequence of tasks that they had to do, but it was really just using allocentric and egocentric tasks to get this done, to see how they could like work their way through the maze. And then synesthetes performed significantly better on the allocentric and egocentric tasks that best mimicked reality. And this was relevant to the response time. And just some of the findings in this, synesthetes performed significantly better and allocentric and egocentric tasks, which I just said. This was reflected mostly by the time they did that, which isn't too surprising as a lot of psych studies are. An exploratory analysis reveals that there are no differences between performance and manifested locations, and then their hypothesis for this was obviously not confirmed. And then some of the basic conclusions is that there's no one way to diagnose synesthesia or to study certain types of synesthesia. There's a lot of methods. It could be very beneficial, and the experiments could be biased. That's again why there's a lot of different ways, and replication is key. So over time, the more you replicate it, obviously, the more valid it would be. And that's about it. Thank you.